All right, awesome. So I'm excited to welcome you all to today's MCLS special. So we have a fantastic session lined up, led by Vijay Marapudi. Vijay is a PhD student at Georgia Tech, working with Sashank. And Vijay's research is focused on how people learn, generate, and use abstractions and concepts with a special interest on unsupervised learning. So in this workshop, Vijay will guide us through designing an online experiment using jsPsych. So he will show us how to make a simple magnitude comparison interface, design and collected from this experiment, so the reaction times and accuracy. Please feel free to ask clarification questions throughout the session. However, keep in mind that the special will be uploaded onto YouTube later, which you can review. And also, Vijay's been sending out a link to the slides and examples for the special today. And so you can also access the slides prior to beginning. Let me go ahead and turn on captions really quickly here. Okay, so let's go ahead and begin. I'll let Vijay take it away.
Thanks, Nick. Just gonna share the screen here. And people see the slides. Okay. Sweet. Okay. Yeah, I put a link in the chat. Should allow you to get the slides. And there's examples there that I'll refer to. So yeah. Okay, let's get started. So before I talk about jsPsych, I just want to talk about online experiments in general. So there's many advantages, of course. You collect a lot more data. I've noticed that students are less likely to come into a lab these days. So even students from your own university, it's easier to collect data. Increased diversity, you collect reaction time data, which I've noticed is like a pain point for people who use Qualtrics for online experiments. But jsPsych makes it easier to collect that. It also shorter experiments, so it doesn't have to take an hour because people don't have to come in person. And I've found this is an underrated advantage. You can have online demos of your experiments. Makes it really easy to explain to people what the study was like. And yeah, the study you make today probably will run the same way like 10 years from now. Okay, so there are some limitations to online experiments, and the reaction time has like some noise. The noise is like 2 seconds or so, 2 milliseconds or so. So most experiments, this should be fine, but just know that requires a little knowledge of these languages, JavaScript, HTML, and CSS. But don't worry about that. It's not that much knowledge. We'll talk about it today. Yeah, and uploading data to a server is slightly more effort than saving it locally, but also not too hard. I have instructions written down in the slides on how to do that. Data quality is a bit more variable, so make sure you have attention checks. And integrating with physical devices is harder. Just keep that in mind. So here's some terminology before we begin. I'll use these words occasionally. So the client or the browser is what the participant uses. So like Google Chrome or Firefox, it's what's run and displayed for them. And it involves HTML, CSS, and JavaScript. HTML is text that describes the structure of a page. I'll show you what that looks like, so don't worry about it. CSS is text that describes how that structure should be displayed to people. And then JavaScript handles like how events such as clicks or pressing a key, how that changes the HTML or CSS. And finally, a server or the cloud just means someone else's computer. That just determines what the client gets when they request something and what they're going to see. Yeah. So what is jsPsych? So jsPsych is only like one part of the larger system in which you collect data online, and I'll provide an overview soon. But it takes care of the JavaScript part and some of the HTML and CSS part. So most of the JavaScript you write will be specifically about your experiment. You don't need to do any plumbing that's required to like handle the data and filter it and all that stuff. So jsPsych takes care of that for you. Yeah. So here's the wider architecture of an online experiment. So the client is pretty much like the participant. They navigate to a URL. And then the URL is the server. The server is like, okay, here's this HTML file. Then the client reads the HTML file, and then it's like, oh, the HTML file says I need more things like images or JavaScript. So then it asks the server for that, which then sends those. And finally, the client has everything it needs. So it then displays the experiment and starts running the code. So this is the part where the experiment happens. And then after the experiment's done, the browser or the client uploads the data. The server then stores the data. And then finally, the client displays a completion message or code. So the parts that jsPsych can help with are these. So the other parts aren't too hard. I'll talk about them soon. But yeah, it takes care of displaying the experiment and requesting resources. So the first part is usually getting a link to participants. So you can use like Prolific or mTurk online recruitment platforms, or you could just use email or your university's like system to get participants. For the server part that sends the files, there's free options. It's pretty simple. It's called GitHub or GitLab Pages. You can just upload your files there and it'll take care of everything. Not too hard. And then finally, the data storage server. There is a free option. It's jsPsych and OSF, or the Open Science Framework. That's what I'd recommend, and I outline steps on how to use that. But yeah, there's other things you can use for this too. But most of these are not that complicated, so I wouldn't. Yeah, I know it seems like a lot, but it's not too hard. Yeah, and I link to these in this slide, so if you want to look at them, you can. Yeah, so today we'll just focus on this simple thing. The jsPsych like gets all the resources and displays the experiment, runs the interface, and then displays the completion message and code. And yeah, we'll see what the data looks like as well. So good to start with, I'm gonna show you what the basic HTML file looks like. So this is the hello world of HTML. So might look like a lot, but it's think of it as like a hierarchical tree. So every HTML file needs to have this. So you can just copy paste that and then ignore it. Then there's each HTML consists of elements, and elements have children. So here's like a HTML element. Here's the opening tag, and here's the closing tag. So everything in an element are its children. So in this HTML text snippet, the HTML file has a head tag and a body tag. And the head tag has a title tag. And then here the title is My Experiment. This is the title that they see in their tab. So if you go to the website, that's what the text is on the tab. And we'll open this example. So anytime a slide has this like square bracket E1, that's an example that's provided in the files. Yeah, so there's a head, and then there's a body. So the body here has a P tag, which means paragraph. So it has a paragraph with the text hello world, and then it has a script tag with nothing in it. So first, let's look at what this looks like. So I'm assuming people can see the file browser. Okay, good. So that's what this looks like. Just some text on a page, nothing else really happening, and the name My Experiment on the tab. So yeah, that's the base HTML file on which we'll build the jsPsych experiment. Yeah. So how do you use jsPsych in a HTML file? So you'll need to add this part to the head tag. And I'll explain what this part does. The first line, the script source line, just says, go to this URL and please download the JavaScript and execute it. So this is the jsPsych library. This just says, get jsPsych and please run jsPsych's code. The second line, the second, I guess, two lines, or the second and third line, says, this, the link href style sheet, just means this is the CSS. So this is the aesthetics of the experiment. So jsPsych needs some aesthetics or CSS by default. And this is how you get that. So you just say, get it from this URL and then run it. And if you're worried that this just seems like just random stuff all of a sudden, this is good. This is in the jsPsych tutorial and instructions on their documentation. So yeah, I literally just copy pasted it from there. So it's pretty much just copy pasting. And then finally, there's this line where you're saying you want the plugin HTML keyboard response of jsPsych. So jsPsych can be thought of as just a list of plugins that are then run and displayed to participants. So this is a plugin that we will use. So we just want the HTML keyboard response plugin. So the name of the plugin is usually like what is displayed and then how the participant responds. So here the HTML is displayed and the participants respond using a keyboard. So yeah. So then here's the hello world of jsPsych. So this is how you use jsPsych to create an experiment. Right. So usually, yeah, thanks for the question. So usually you're typing this code in a text file. So let me actually show you. So I'm going to open example 2. So this is what it looks like. It's just a text file with the extension .html. Yeah, if you look at example 2, that's the hello world trial that's on the screen. Yeah, so you just type it out here, save the file, and then you open it in a browser or you double click it. Usually the browser will open it. Yeah. So yeah, this is the hello world. So in the empty script tag that was in the body, I just added code. So here's what the code does. The first line initializes jsPsych. So that's the init jsPsych function. And it returns, you can say it returns jsPsych. This is how you use jsPsych. So you save that to a variable. In JavaScript, you usually declare variables using const. So this says the variable jsPsych is equal to whatever the init jsPsych function returns. And then you create a trial object. So what that means is an object is usually a set of key value pairs. So the key is like, in this case, there's 2 key value pairs. One is the keys are type and stimulus, and the values are jsPsych, HTML keyboard response, and then hello world. So this represents a trial. So we're saying for this trial, its type is a keyboard response trial. And then the stimulus, the thing we want jsPsych to display is hello world. And since it's a HTML keyboard response plugin, the stimulus can be any HTML. So this is very simple. This is just text, but we can throw in whatever HTML we want in there and it will display it. And then finally, we're saying, hey, jsPsych, run. Here we're creating a list. So it's kind of like the C function in R, if you know that, like it's just making a list of items. So making a list of a single item, which is the trial. So this is a one trial jsPsych experiment, but it works. So I'll just run it. So let's go here, example 2. So that's what the trial looks like. Hello world. As you can see, jsPsych did some nice things for us. It centered the text, unlike the bare HTML example. And the font is also not like the awful default font. It's a much nicer font. But yeah, so how do we respond? Well, it's the HTML keyboard response plugin. So we respond using the keyboard. So I'll press a key, and that's it. The experiment's over. Not very useful, but that's the hello world of jsPsych. You had a trial and you responded to it. Yeah. So obviously you need to do some more things to make it useful. So we'll talk about how to do that. So first I want to explain one common confusion people have, which is like, where are these names coming from? And usually the way I would answer that question is to remove things from the head section to figure out what's bricks. But in this case, I will tell you where things are coming from. So the init jsPsych function is coming from the jsPsych library, which is loaded by this line here. The jsPsych HTML keyboard response like variable is coming from the plugin loading line here. And then, yeah, the CSS is this isn't really like responsible for anything in the JavaScript part, but it's making the page look nice. So if you remove this, you'll see that it's nothing centered anymore. It all looks bad. So that's what this is doing. So yeah, that's the basic structure. So how do we go forward? So most of the edits to the HTML will now mostly be adding trials and plugins. The JavaScript part is where most of the experiment lies. You will rarely edit like the larger HTML file. But yeah, first I want to show you what the data looks like. So instead of just saying init jsPsych, now we will tell jsPsych to do more things. We will pass it an object or key value pair. We'll say, hey jsPsych, when you finish, run this function. And what does this function do? This function displays the data as a JSON in the JSON format. I know jsPsych has the feature to use CSV. I will recommend you don't do that for your future sanity when you're cleaning the data. So I will show you what JSON data looks like, and I'll show you how to load it into R. So don't worry about using JSON. So yeah, that's the only change we made. We told it to display the data after the experiment's over. And yeah, let's run that example. Example 3. Let's double click that. Okay, I'm gonna press a key. And now it displays the data. So it is a list of a single object because there was only one trial, and that's this object. And then you have a reaction time. So from when it was displayed to when the person responded. And then you have what you added to it, the key they typed, and then just metadata, like what plugin this was, which like index, or how many plugins has it been since this one was shown, etc. So yeah, the data is pretty readable, and it's mostly going to be a list of objects like this. And you can load this into R pretty easily, and I'll show you how to do that towards the end. But yeah, don't use CSV. Okay. Okay. Yeah, I already talked about this. So that seems okay, but what else can jsPsych plugins do? jsPsych plugins can do a lot of things. They can display like images, audio, HTML, which is like the nuclear option. You can do anything with HTML really. And then there's like multiple choices, Likert skills, forms, etc. So you can replace all the things you use Qualtrics for with jsPsych as well. And there's many types of ways of responding. You can have free response texts. You can have like a Likert style slider. You can ask them to speak into the computer. So if you want like think aloud data, you can use jsPsych for that. It's just keyboard responses. You can show buttons on the screen and they can click them. But yeah, there's many other types. If you go to the jsPsych website and go to the plugins section over here and the list of plugins, you get a pretty good overview of the plugins. There's actually more than those are listed here. So if you scroll to the side, you can see all of them. But yeah, most experiments I think can be done in jsPsych. And even when you do them using the built-in plugins, you can make your own plugin. It'll take a little bit more knowledge, but it can be done. And it's usually pretty reliable once you make it. You can usually copy an existing plugin and edit it. But for now, for this special, we're going to stick to using the built-in plugins. Yeah, we talked about this. So
Hey,
yeah, for
VJ,
this, yeah.
we just have a quick question in the chat. So
Mhm.
the question is, what types of data loss can you experience if you save data to CSVs?
Yeah, so you'll have data loss when you have like let's say a plugin results in a list of data instead of just one data point. For example, the HTML response plugin has one reaction time, but then if you might have a plugin where you have multiple reactions, like the participant has to respond to 3 things at once. And then if you want to lose the data, it'll be in the CSV. It's just that cleaning that data will be really, really hard because CSV is not designed for anything but tabular data, like anything that'll fit in a table. But JSON can represent many other types of data, and it's easier to convert JSON to tabular data than to convert weird tabular nested data into a structure you want. So yeah, that's why I recommend using JSON. And another thing is that JSON saves the types of the variables. So if you have like a number, when you load it in R, it'll be a number. R won't have to guess that is this text, is this a time? It doesn't have to do any of that. It's pretty straightforward. Yeah. Okay. So yeah, I want to now talk about making a magnitude comparison experiment since we have all the basics for jsPsych. So here's how we'll structure it. I want participants to see 2 numbers on the screen, and I want them to say which one is larger. So press the Z key if the one on the left is larger, and the M key if the one on the right is larger. So pretty standard magnitude comparison task. I don't want any other keys to be pressed. If participant presses those, I don't want to move to the next trial. I want it only the Z and the M keys. And let's make it 10 trials. And then let's generate the 2 numbers randomly. This is just for convenience. You can import your pre-generated stimuli pretty easily by converting them to the JSON format using R. So you can just have like a CSV of your stimuli and then use it in JavaScript by converting it to JSON. Yeah, but for now, we're just going to randomly create the stimuli. Okay, so how do we accomplish this? First question is always, is there a plugin for this task? No, there's no plugin for this task. So here's an example where you have to do something custom. Obviously, if there's a plugin for this task, you just use the plugin and this presentation would end. But I wanted to give you an example where you have to do something a bit more custom, which is often the case for magnitude or just like math cog work. Because and also most experiments have their own niche stimuli, so you'll have to create it. So can we use a HTML plugin for this? HTML, I'd say, is like the very flexible option. So in this case, we can, because HTML can display a very wide variety of things. Like unless your stimulus is 3D, it's like a game, HTML can take care of it. So most of the time, HTML can do this, do the job. And is there like a HTML something response plugin that collects the data we want? Yep, we just used it. It's the HTML keyboard response. Displays HTML and the participant responds using the keyboard. Perfect. So we're going to use that plugin. So just to show you where I want to go, this is what I want a trial to look like. Two numbers shown to the sides. And then I want some instructions at the bottom so that the participant knows which keys to press in case they forget. So how should we think about structuring this? So typically you would want to first start with a hierarchical structure. Personally, I see a row over here and a row over here. This row has like 2 columns. There's only one thing in this row, so it has no columns. And this is how I'd think of it. So whatever, there's a base, and there's 2 rows. And in the first row, there's some text. And then there's some space between the text. And then there's more text. And in the second row, it's just the instructions. Yeah. So how do we actually convert this to HTML? Well, if you Google this, you'll see a lot of stuff like, oh, you should use X, Y, Z. My recommendation is use the div tag for everything. So what the div tag in HTML is just like a container. It just says, I hold these things. It's like the most generic option you could use. And don't overthink it. When in doubt, just use the div tag. If you Google things online, they're going to give you best practices for search engine optimization and stuff, which you're not going to need for your experiment. So just use the div tag for everything. So what would that look like? We have a base div element that has 2 children that are also div elements. And each of the children have 3, this child has 3 children, each of which are div elements. So this div has 34 in it. Then there's a spacing div, and then there's a div with the text 45, and then there's a div with instruction. So what does this look like? So this is what that HTML would look like, that tree structure I described. There's the base div tag, there's the beginning, there's the end, and then here's the first row. There's the first div with the text. Then there's an empty div with just, this is going to be the space, right? But there's nothing in it. We'll add the space later. And then there's the other text. And then we close the first row. And the second row has another div, and then there's like text in there. Yeah, so usually when you're designing this stuff, you want to know what stuff looks like. And it's kind of annoying to have to like type it out, save it, double click it, open it in the browser. I link this later in the slides, but I recommend using the website flems.io. It's pretty much a live preview website. So if you type in HTML here, I'm just typing some text, it'll show you what that looks like. So here's an example where I have 2 paragraphs. I have a P tag and another P tag. And that's what 2 paragraphs would look like to the person seeing the experiment. So for now, I have another copy of the slides here so I can copy paste easily. So I'm going to go to this. I'm going to copy it. I'm going to paste it in the HTML part of the Flems. And that's what it looks like. So if you just type in the HTML, that's what you'll see. It's not what we want, but that's what you'll see. You see that 34 and 45 are not next to each other. There's no real space anywhere. And yeah, this is not looking like what we want. So yeah, we'll need to add some aesthetic stuff to make it look like the way we want. Yeah. So I'm just going to change how this is. It's the same text. I'll put each item in that div in its own line. So it's the same text. Yeah, so because it's just going to be easier to read when I add stuff. So yeah, as I've said, HTML is not, just HTML is not enough. So we need to add CSS. And yeah, use the flems.io website to test stuff. So what is CSS? CSS is like a bunch of attributes with values. So one example attribute is you can say, this element should be 100 pixels wide. Another attribute could be, I want the font size of the things in this element to be like 100 pixels, 100 points. So that's what CSS allows you to do. And you can add that in using the style tag, style attribute in HTML. So let me show you an example. So here, I want to make this text, let's say, red. So add a style attribute like that, okay? Then I'm going to say color, red, semicolon. And now the things in this element are red. So you can do other things. You could say, I want the font size to be like 60 point. So now it's massive. So CSS allows you to manipulate like how things are displayed. So now going back to the experiment, what CSS would you need? Consider this a general tip whenever you're making any of your experiments. Think in terms of rows, and then you can use the CSS variables for that. So if you want to display a thing in a row, use display flex. So whenever things are displayed vertically, this makes things be displayed horizontally. And then whenever you want things to be centered horizontally, use justify content center. So for example, we can just do that here. I'm going to remove this very distracting style. So in the row, I'm just going to be like display flex. And now you see that 35 and 45 are right next to each other. Okay. But they're not centered. So I want them centered. So I just say justify content center. And now they're centered in the page. Perfect. If you notice, there's no space. So let's add some space. So you see the spacer element here. Here we should add a width, right? Let's make it, I don't know, 100 pixels. So it works. But generally, just for future-proofing the code, I would add this property, flex shrink 0. So what this does is it tells the whatever it's using to make it a row to not make this smaller if it wants to make it smaller. But that's just something you should do for the future. But yeah, now this kind of looks like what we want. It's in a row, and there's some space between it, right? Looking closer to what we want the experiment to look like. Yeah, so in the actual code, in the example that I'll show soon, I use a different unit. I don't use pixels. I use VW, which is like a percentage of the screen. So I usually recommend using these because screen sizes differ. And if you want your experiment to run on all of them, it's good to be relative in how you prescribe widths. So yeah. So we say, yeah, don't shrink the element, the spacing element. So yeah, that's what the HTML looks like now. Pretty much what I showed you. Okay. And now some quality of life changes. Align the instruction text, right? You want it to be centered. Add some space so that the instruction text isn't like immediately below the items. We want some focus to the experimental items. And then change the text to be. So what would that look like? We add those to the div that contains the instructions text over there. So yeah, just take some time to like make sense of that. And yeah, I'll have an examples coming up soon that shows you what this looks like. Yeah. And then I will make one more change because I want the items, the numbers to be large. I want them to be big, so that's where attention goes. So I'm just going to add font size 80 pixels to the row, which contains the text. So anytime you add a CSS property to a parent element or parent HTML tag, all of its children inherit the property. So you don't have to do this for every single time, every single div that holds text. So if you look here, it's enough if I just add it to the top one here. And yeah, this is a pretty much done deal. This is what the HTML for a magnitude comparison trial should look like. And yeah, let's go to the example here. It's example 4 here. So obviously it's not centered because I'm not running it in jsPsych, but jsPsych will take care of the centering, like vertical centering. But yeah, you get two massive numbers, and then you have some small instruction text at the bottom. This is what a magnitude comparison trial should look like. Perfect. Now we want this to work for any arbitrary number. We don't want to just type in manually each number. So we need to make it a function. This is what a JavaScript function would look like for this. Here's the function. We're just saying this is a function. Here's the name of the function. Here it takes two variable inputs, the left number and the right number. Okay. Then it returns a string, pretty much. A backtick string in JavaScript just has like a special feature that allows you to add the variables inside the string. So if you do like $, open curly brace, and the variable name, close curly brace, it'll just insert that inside the string for you. Just returning whatever HTML we just made, except instead of hard coding the numbers, those numbers are the variables we pass to this function. Yeah, it might take some time to understand how this works, but once you get it, it's pretty intuitive, and you can reuse it for all sorts of things. Yeah, so how do we convert the jsPsych hello world experiment to use this function? Well, we copy that function that I just showed you into the file before the jsPsych part, and then we change the stimulus line of the trial object. So before this said hello world, a string. Now we use the function make comparison stimulus, and then we pass it the numbers as so I want to show you what this looks like. So let's open example 5. So here's where it starts, and then here's the function I defined. I just put it in there before the jsPsych part, and then that's initializing jsPsych. And now we have the part on the slide. You make the stimulus here. So this returns a string, which is then interpreted as HTML by jsPsych, and it displays that on the page. So yeah, this is a functional experiment. So let's open it. Well, experiment is saying a lot. That's what this looks like on a web page. It's a magnitude comparison trial. You see two numbers, you have to press keys to respond. So I'm going to press a key. That's it, it's done. So you have reaction time, and you know which response you know what response participants provided. So this looks like it's ready, but don't be too fast. There's some sanity checks you want to do. We don't know which numbers we showed people. So save that for our future self so that data cleaning is easier. You can read the HTML you generated and extract them out manually, but I would not recommend that. Yeah, but it works. And there's also another problem. I can press any key I want. I can press space, and it'll take space. So the response was a space. So there's some like sanity checks you got to do. Yeah, already talked about this. So this is how you do it. It's not too hard. You say for the choices, participant only has like two choices, the Z and the M keys. And then you can provide a data saying, save this as part of the output. So the left number is 34, the right number is 45. So if you go to example 6, that's what that will be like. And I'll just do it here. And you'll see that it is much nicer to work with. So yeah, I'll press M here. It worked, right? Now you have the left number and the right number, and you have their response. you have all the information you need to figure out whether the response was correct or not. And you can do this post-processing in R. Yeah. And now I can't press any other key. Like I'm pressing space, nothing happens. F, nothing happens. You have to press Z or N. Yeah. That's how you do a good single trial experiment. But I mean, for a real experiment, you need to do a few more things. For the interest of time, I will not discuss all the things, but we can talk about it in the questions if you're interested. But yeah, this is one change you can do to actually get the data as a file instead of just showing it on the screen. Yeah, this is just how it works. You can save that as JSON, and we'll run this example, so you'll see what that looks like. Yeah, we generalize it to 10 trials. So I generate 10 trials by using random numbers, add it to a list of trial objects instead of just a single trial object. And then I tell jsPsych to run that list of trial objects. So if you look at example E7 and like we look at the file, you'll see how I accomplished this, but it's not that much more code. I added some pre-trial instructions and a post-trial message. And yeah, you can give it a shot right now. I mean, I will do that live. Nothing like a live experiment. Okay, so this is what it'll look like. And the only plugin I use for this entire experiment is HTML keyboard response, nothing else. And if with other plugins, you could do a lot more. So yeah, you will see two numbers on the screen, one to the left, one to the right. The task system indicator which number is larger. But yeah, these are just the instructions. Space. I'm gonna just actually try do this. Okay, so the experiment's complete, and I have like a transition trial space. And yeah, it downloaded the data. And you can typically show them like a completion code that they can type into Prolific or mTurk to then register that they completed the experiment. Obviously, you should make the code so that they can't guess it. Prolific just gives you a random code that you have to put in there. But yeah, they won't be able to register the completion without this code. Yeah, so yeah, that's like a basic experiment. Let's see what the data looks like. So I'm gonna be in my downloads folder. It's gonna look like a mess. But it's not a mess organized. As you can see, it is a list of like many objects. So here's one object, which is the first trial. Then here's the second object, the second trial. See, it has a left number and a right number. Yeah, so everything is in here. It's just multiple of the objects that I showed you on the screen before. Yeah. Okay, let's go next. So how do you load the data in R? You should use this function. Just for the interest of time, I will skip doing that myself, but this is not that hard. Just install the JSON-like package, put the file name, and then tell it to simplify. And then you can take care of everything else in R. So there's some more polish required. I'm not going to do this now, but obviously you want to show consent forms. You can use the form plugin for that. You can show instructions. There's an instruction plugin. You can have timeouts. jsPsych supports a timeout for every single plugin. If they don't respond in a specific amount of time, the plugin is considered void and they move on to the next one. You can have surveys. Yeah, jsPsych has plugins for all of these, so it won't be too much of a thing to do. And then, yeah, I'm going to briefly talk about how to get it online. It's free. I'm not going to do it now because it's just filling out a lot of forms. And I don't think you want to see that. But yeah, I'll just discuss that. So this getting it online, you want to create a GitHub or GitLab Pages account. Just one thing to keep in mind for that is you should use a generic name for the project so that people can't guess your experiment. Like don't say magnitude comparison of fractions, or don't type your hypothesis in the URL. Sometimes I've seen people do that. So make it generic. And yeah, this will give you a URL, like your github.io / and then whatever you put in. So you can just send that to participants and then they can complete the study. And then this is the server part. So I'm going to start talking about that. So this requires two services. If you want to do this for free, if you want to, there's many paid services that you can see in the jsPsych page itself, which are slightly easier, but not that much. Like I would just do the free thing. So this involves creating. So first you sign up for an OSF account. Some of you probably have that already. And then you also make a data pipe account. So what jsPsych data pipe is it's like a service that just it's like shuttles your data. So it takes your data and it's like, okay, OSF, here it is. That's all it does. So you just make a private OSF project, and then you have to create something called an authorization token. It's just like like a line of text. So you just copy that and then paste it into data pipe. And now data pipe is authorized to add files to your OSF project. So then you just need to create an experiment on data pipe, and then data pipe will ID. And then you just use the jsPsych plugin pipe. So it's just a plugin you add at the end of your experiment, and you give it the ID, and it'll just upload the data for you. And after the data is uploaded, it'll move to the next. So after that, you can just show them the completion message. So yeah, just some like details. This is one constant struggle people have, which is how to have conditions in online experiments. And data pipe actually has a very nice utility for this. You can tell it that you have 8 conditions. And then at the beginning of the experiment, you can ask it to assign a condition. So it's like a rolling counter. So if you have 8 conditions, it'll give you like 0, 1, 2, 3, 4, 5, 6, 7, and then it'll start again at 0. So you can counterbalance, you can balance the conditions so that equal numbers of participants do the study. And then also Prolific, if you use that platform, can assign conditions for you. But this time the condition will be the URL, which jsPsych has like a function to extract that information from the URL. But yeah, just make sure, yeah, just keep in mind that this is here. Don't do the thing where people create random numbers and then they're like, it should approximately be 50%. It's not necessarily guaranteed with small sample sizes. So yeah, I would use these condition facilities. But yeah, that's all I've got. Happy to take questions. If you have any like specific thing you'd want to like create or just want me to clarify, yeah, happy to take questions.
Well, thank you so much. I think that we can either take questions in the chat or feel free to unmute and ask a question. I know I have a few questions, so I can just get us started. So I was thinking about a lot of times I feel like in magnitude comparison tasks, like you have a preset list of stimuli that you've like really carefully created yourself. And so rather than randomly generating stimuli in your code or like via your code, is there a way to like import in a list of your stimuli?
Yes. So that usually involves like it's like just copy pasting. So let me see. Let's make like, can you see the R on my screen? Yeah, okay. Yeah. Yeah, let's make some data just randomly. Um, mm, I don't know. It's been a while since this data got flying. Okay. I'm gonna save that clear variable. So now you can use the JSON light to JSON function. Oh, sorry. I got, okay. Yeah. So when you do that, it outputs JSON, right? So this is the same kind of format that we've been seeing. So, I mean, usually you'd want to write it to a file and then copy it from the file. And then when you edit, so JSON is valid JavaScript. So when you open a file, like you see this JavaScript file here, it could just be like const stimuli. And then you can just paste that. So now you can use for loops. So you could be like for the item of the stimuli. And there's an example of that kind of looping over stuff in the final experiment file. Then you can create a trial in here. So you can access item.a will give you like the first item.a, the a key in the first object. You can say item.a or item.b, and then you can create a trial here. So yeah, you can just you can convert anything you can do in R, you can convert to JSON and then use it in the file.
Okay. Happy to take other questions. I guess a follow-up to that is like in terms of, I think in that case you're listing so there's going to be a particular order of stimuli, and is there a way to like randomize that per person? And then my secondary follow-up question is, can you extract that order so that you know like each participant's order of stimuli? I realize these questions may be like kind of complex for a
No,
novice programmer, but
yeah, I mean, it require just some basic programming, but if you can do R, you can do this stuff. So yeah, jsPsych has like a shuffle function, right? So if you have the JSON data like I just made, you can just say like let's just literally shuffle an array of objects. So you could just say JSON.randomization dot repeat, like just copy this and it'll shuffle it. And then you just use the array for whatever you want. And then you can also just save the itself as the data for, you could be like, okay, so this for the, I guess, consent trial, the data for this trial is the order of stimuli that they're going to see. And then you can access that later. So yeah, that's how I would do it.
cool, thank you. And then I just had a question about the reaction time, and I'm assuming that all is like automated in milliseconds then.
Yeah.
Okay, great.
The
And
trial.
then, yeah, cool. And then is accuracy like automatically generated, or do you have to provide some sort of like rule which you've predetermined like which is accurate?
Yeah, so accuracy is not automatically generated. So I'd recommend personally to provide the information that you need to calculate it, but don't calculate it in the trial unless you have to. But you can. So like if you read the documentation, I forget how to get there. You can, for each trial, you can give it a function and just be like, after the trial, run this function. And that function has access to the data from the most recent trial. So in that function, you can calculate accuracy and add it to the data. But like there's actually like legitimate use cases for that. Like maybe you want to provide feedback. Like you want the next trial to say correct or wrong based on whether the previous trial was accurate. So if you want training, you'd have to do such a thing. Yeah, I don't remember off the top of my head where that is. but yeah, you'd have to add it to the trial object.
Great, thank you. Yeah, it seems like what you've like shown us today is a nice like base, which then as your experiment like grows in complexity, you can add more of that like programming and yeah, code to
Mm.
supplement that. So yeah, I really appreciate that. I just want to, I have a couple of announcements, but before we end the special, I want to just open up the opportunity for any last minute questions or feedback. And if not, then I will move on to announcements. Awesome. Thank you so much, VJ. That was really, honestly, I learned so much and I felt like that was really clear. And I want to just also make note that I will upload this recording onto YouTube. So if you followed along this time, but want to try it on your own, I think that you could definitely do that with YouTube. And also, maybe in that YouTube description or the video description, I can link the slides and examples too. And so this will be a resource that people can use in the future as they decide to build their own experiments. And so thank you again, VJ. That was really excellent. And so I want to make a couple announcements for the next MCLS events and organization. And so there will be another special in November, which will be about funding, like grants. So grants and fellowships with for grad students and postdocs. That will be November 7th, and that's 3 to 4 p.m. Eastern time. Last, I want to just make a shout out to the MCLS writing group, which we are hoping to organize. And so go ahead and if you could check out Slack and let us know if you're interested in joining a writing group. So I think that's all we have for today. Thank you again, everybody, for joining us, and thank you, BJ. And everyone have a great week. Thanks. Goodbye, everyone.
Goodbye.
See you, BJ.